everyone, myself Mohammad Kaf, studying in Shri Venkateshwara College of Engineering from CSE department. So today's topic is nearest neighbor learning in AIML. This presentation explores the fundamental of the nearest neighbor learning, a simple yet powerful technique widely used in artificial intelligence and machine learning. Introduction to nearest neighbor learning. A simple approach. Nearest neighbor learning is non-parametric method that clarifies new data points based on their similarity to unknown data points. Key points. The algorithm assumes that similar data points are likely to belong the same class, leverages the concept of proximity to make predictions. Nearest neighbor learning is non-parametric parametric method based on the similarity to unknown data points. The concept of similarity measures. Euclidean distance calculates the straight line distance between 2 points in a multi-dimensional space. Manhattan distance measures the distance along the axis of the coordinate system, representing the system of absolute differences. Cosine similarities determines the angle between two vectors, measures the similarity based on the direction. There are three concepts of similarity measures. First one is the Euclidean distance, second one is the Manhattan distance, third one is the cosine similarities. These are the concept of similarity measures. Next is the K nearest neighbor algorithm, that is known as the KNN algorithm. Steps in the KNN algorithm. First one is the calculate the distance between the new data points and all existing data points. Step 2 is the identify the K nearest neighbor to the new point to the class that among its the K nearest. This is the basic advantages of KNN. There are three advantages and disadvantages of KNN. In advantages, it is simple to implement, parametric, no assumptions about the data distribution. Third one is the effective for high dimensional data. Disadvantages: sensitive to noisy data, computational complexity increases with the data size. Third one is that choosing the optimal value of K can be challenging. These are the advantages and disadvantages of KNN. Simple to implement, non-parametric, no assumptions about the data distribution, effective for high dimensional data. Disadvantages are the sensitive to noisy data, computational complexity increases the data size, dataset size. Choosing the optimal value of K can be challenging. Next is the application of the nearest neighbor learning. First one is the image recognition, second is the recommendation system, third one is the fraud detection. Under the image recognition, we see classifying images based on the visual similarities to existing examples. Second is the recommendation system, suggesting products or content to users based on their preferences. Third one is the fraud detection, identifying fraudulent transactions by comparing them to unknown fraudulent patterns. Image recognition. Next is the challenges in nearest neighbor learning. Curse of dimensionality, data scalability, and choosing K. First one is the performance degrades with increasing dimensionality. The second one is the data scalability, computational cost set. And choosing the K means finding the optimal value of K is the performance performance degrade with increasing dimensionality. Computational cost grows with larger data sets. Third one is the finding the optimal value of K. The challenges in the nearest neighbor algorithms, that is known as the KNN algorithm, because of dimensionality, data scalability, choosing K. set choosing k, finding the optimal value of k is a crucial factor. Next is the advancements in the nearest neighbor learning. First one is the approximate neighbor search. Second is the dimensionality reduction techniques. Third one is the adaptive KNN. For the approximate nearest neighbor search, faster search methods to overcome the dimensionality challenges. Second is the dimensionality reduction. Approximate nearest neighbor search, dimensionality. Next is the future trends and conclusions. First one is the hybrid model, second is the explainable AI, third one is the edge computing. Combining nearest neighbor with the other learning methods are the hybrid models. Improving interpretability and understanding of decision are the explainable AI. Deploying nearest neighbor algorithms on rescue constrained devices are the edge computing. Hybrid models, explainable AI, edge computing. These are the future trends and conclusion of the in AML.